Here's an example for you. If I say a dozen, you should automatically think of the number 12 because that's what a dozen means. In the same way, we have a dozen that we use in chemistry, but it's a little bit different. We have the mole. This is not the little fuzzy creature. It is instead a number that means 6.02 times 10 to the 23rd. That's a huge number, so here's how big that number is, just in case you were wondering. That's the same number right here as this right here. It's huge. This number is really, really useful in chemistry though, so that's why we decided to go ahead and give it a name, call it the mole, and it makes things a lot easier when we're talking about the number of atoms within a substance. It helps us to figure out how chemical reactions will work and that kind of thing. So when I say a dozen, you think 12. When I say a mole, you should think 6.02 times 10 to the 23rd. Knowing that, if we know that a dozen is equal to 12, then 2 dozen is equal to 24, and 3 dozen is equal to 36. These are numbers that we've used over and over again in our lives. They should be pretty familiar to you. Chemists will use the mole in the same way. So over here, 1 mole is equal to 6.02 times 10 to the 23rd, 2 moles is equal to 12.04 times 10 to the 23rd, and 3 is equal to 18.06 times 10 to the 23rd. This concept can be a little bit difficult at first, but if you just think about it as if it's like a chemical dozen, it can be pretty helpful. And there are some other YouTube videos out there that will help you kind of get a better understanding of what's going on with this as well. But essentially, at the end of the day, chemists needed a way to take a shortcut on writing all of those zeros and saying 6.02 times 10 to the 23rd over and over again. So we decided to call it a mole, and we abbreviate it by writing MOL. If you were to write M, that would mean meter. So we don't do just M, we do MOL. So with that, if we were to do some practice here, how many particles are in 4 moles and how many particles are in half of a mole, you'd be able to figure this out by doing factor label method, which you should have done already at this point, but here's the review. You take the thing that you're given, in this case 4 moles, and you draw your crosshairs, and we're gonna do our conversion factor. If 1 mole is equal to 6.02 times 10 to the 23rd particles, or things, or atoms, or molecules, whatever, then we can use that conversion factor here to go that 1 mole is equal to 6.02 times 10 to the 23rd, and we can multiply across the top, and we can end up knowing that 4 moles would be the same as 24.08 times 10 to the 23rd particles. Same down here, half of a mole. To set this one up, some of you guys will just know to divide 6.02 divided by 2, but if you wanted to set this up, it would look like this. And your answer would end up being 3.01 times 10 to the 23rd. That's how moles work. It's just like a dozen. If you were to say half of a dozen would be 6 and 4 dozen would be 48. 4 moles is 24.08 times 10 to the 23rd. Half of a mole is 3.01 times 10 to the 23rd. It's just a useful number.